The impossible fact. Scientists have now confirmed something that sounds impossible at first hearing. According to the deepest experiments in quantum physics, the distance between you and a galaxy 13 billion light years away may not exist in the way your brain experiences it. Not metaphorically, not poetically, physically. The galaxy NGC 1300, a massive barred spiral suspended deep in the constellation Eridanus, appears unimaginably far away. Yet modern quantum mechanics suggests that, at the most fundamental level of reality, the separation between you and that galaxy is not absolute. In a very real scientific sense, the universe may be operating as one connected system. And the unsettling part is this. This is not science fiction. This is not philosophy. This comes directly from peer-reviewed experiments. By the end of this journey, you will understand 3 ideas that completely change how we think about reality. First, you'll understand what Bell's theorem actually proved, in simple language, without losing the terrifying implications hidden inside it. Second, you'll understand the holographic principle, the idea that the universe may not fundamentally exist in 3 dimensions at all. And third, you'll understand why some physicists now believe that consciousness itself may play a role in constructing the experience of space. Because once you follow the evidence all the way down, the line between you and the universe begins to dissolve. Hold your hand in front of your face. Look carefully at the space between your eyes and your fingers. Your mind tells you there is distance there, empty space, a measurable gap. But physics says something very different. The air between your hand and your face is filled with trillions upon trillions of molecules. Each molecule is made of atoms. Each atom is mostly empty space. And the electrons inside those atoms do not exist as tiny solid balls orbiting neatly like planets. They exist as probability clouds. Until an interaction occurs, their position is not fixed. It is only a range of possibilities, which means the solid world around you is built less from objects and more from probabilities becoming experiences. The gap between your hand and your face feels real because your nervous system constructs it as real. Now expand that outward. The distance between you and your chair, between Earth and the moon, between our solar system and distant galaxies. Quantum physics says these separations may not be fundamental properties of reality itself. They may be relationships created through interaction. And this is where one experiment changed physics forever. In 1935, Albert Einstein, Boris Podolsky, and Nathan Rosen published what became known as the EPR paradox. Einstein hated what quantum mechanics implied. He believed reality had to obey local realism, the idea that objects possess definite properties independent of observation, and that nothing could influence something else faster than light. To Einstein, space separated things absolutely. Cause had to travel through distance. Nothing else made sense. But then came John Bell. In 1964, physicist John Stuart Bell developed a mathematical test capable of deciding whether Einstein was right or whether quantum mechanics was hiding something much stranger. Bell showed that if particles truly possessed hidden pre-existing properties, then their behavior would obey specific mathematical limits. These became known as Bell inequalities. If experiments violated those inequalities, local realism would collapse. And that is exactly what happened. In 1982, physicist Alain Aspect performed one of the most famous experiments in scientific history. He created pairs of entangled photons, particles linked together through quantum interaction. The photons were separated by large distances, then measured independently. According to classical logic, each photon should already know its own state before measurement. But the results shattered that assumption. The particles behaved as though they were still connected, instantly. Not at the speed of light, not almost instantly, instantly. The correlations between them violated Bell's inequalities exactly as quantum mechanics predicted. Einstein's picture of reality failed, and physicists kept testing it again and again, for decades. Better equipment, longer distances, more precise controls. The result never changed. Finally, in 2015, loophole-free Bell tests conducted simultaneously at Delft University, NIST in Colorado, and the University of Vienna closed every major escape route. The verdict was devastating. Local realism was dead. Either particles do not possess definite properties before measurement, or information is connected in a way that completely ignores spatial separation. Either option destroys the classical meaning of distance. And now we reach the part most people never fully absorb. Entangled particles do not care how far apart they are. 1 meter, 1 light year, a billion light years. The mathematics behaves the same. Distance is not part of the connection. This is what physicists mean by non-locality. Not merely communication faster than light, but something deeper. The connection exists outside the framework of space itself. The relationship comes first, space comes later. Now think about the beginning of the universe. Every particle in existence emerged from the same primordial quantum state during the Big Bang. Every atom in your body, every atom in distant galaxies, every photon crossing the cosmos, all originated together, which means every particle in the universe shares a quantum history. At the deepest level, the universe may still be one entangled system. The separation between things may not be fundamental reality. It may be an emergent experience. And that brings us to the holographic principle, one of the strangest and most influential ideas in theoretical physics. Developed from black hole thermodynamics and later formalized through Maldasena's ADS-CFT correspondence, the holographic principle suggests something almost impossible to visualize. The information describing a three-dimensional volume of space may actually exist encoded on a two-dimensional boundary. In other words, the universe may function like a hologram. Everything you perceive as depth, distance, and location could emerge from deeper informational structures underneath space-time itself. Space may not be fundamental, it may be generated. And if space is generated, then what generates it? That question leads directly toward observation, toward consciousness, toward you. Some physicists, including Carlo Rovelli through relational quantum mechanics, argue that properties in the universe only exist relative to interactions between systems. There is no absolute view from nowhere, no cosmic camera floating outside reality measuring objective distances. Every measurement is relational, which means distance is not simply out there waiting to be discovered. It is part of the interaction itself. And now comes the realization that unsettles people the most. If distance emerges through interaction, and if conscious observers are part of those interactions, then observers are not passive beings sitting inside space-time. Observers participate in constructing the experienced framework of space-time. You are not simply inside the universe. You are one of the processes through which the universe becomes observable to itself. Now be careful. This does not mean you control reality with your thoughts. It does not mean physics proves spirituality. The science does not say that, but it does say something equally unsettling. The universe appears fundamentally relational, not object-based, information-based, not distance-based. At the deepest layer we can experimentally access, reality behaves less like separated objects moving through empty space, and more like an interconnected informational structure. And once you accept that, the question changes completely. The question is no longer, how far away is that galaxy? The question becomes, what does distance actually mean? Because the universe you experience may not be built from space first. It may be built from relationships first. And space is what those relationships feel like from the inside. Now imagine what happens if time behaves the same way. Because modern delayed choice quantum experiments are beginning to suggest something even stranger. The order of events themselves may not be fundamental either. Some experiments imply that future measurements can influence how past quantum events are described, not science fiction, peer-reviewed physics. If space is emergent and time is emergent, then reality becomes something radically different from the mechanical universe we once imagined. The universe may not be a machine existing inside spacetime. Spacetime itself may emerge from deeper informational processes underneath it. And you, the conscious system experiencing this moment, are part of that process. So sit with this question carefully. If the distance between you and the stars is not fundamental, if separation itself is partly constructed through observation, then when you look up at the night sky and feel awe, are you observing the universe? Or is the universe observing itself through you?